it's been implied that, maybe there's something weird going on, if there's a techno signature, blah, blah, blah. A lot of this actually came from Avi Loeb at Harvard.
Right.
But then he came out with this model, which is a physical model for the ice coma of 3I Atlas. Not a normal comet, kind of a weird comet, but just ordinary physics. Okay, one of the things that it tries to explain is something called the anti-tail. This was very weird, right? This is from the Hubble Space Telescope. On the right is where the sun is, and there's some projection. There's like a jet from the comet coming out towards the sun.
Which is counterintuitive because the idea would be if the comet is traveling at high velocity towards the sun, you would imagine the quote unquote jet would be pointing in the opposite direction.
And there is one. Yeah. So the anti-sun tail is kind of behind the comet and the sun-facing one is towards us.
I get
so
that.
because of our vantage point, it looks like the sun-facing emission is that much brighter, but that's not actually true. But in any case, there is a sun-facing emission, right?
Okay.
And then when it went past post-perihelion, so it went past the sun on the other side, now there's no towards the sun tail. There's only the anti-sun tail. Okay, so it disappeared. This is from the Very Large Telescope, the VLT in Chile. So the nucleus has done this thing where it had jets pointing in both directions.
Yes.
And then on the other side of the sun, it no longer has that.
Yes.
So what's going on? The model is the following, okay? So when the comet is coming towards the sun, there's going to be something called sublimation. Sublimation is what happens with dry ice, where you go directly from a solid form to a gas form. Now, when it's happening and it's coming towards us, that sublimation is actually going to cause chunks of CO2 to sort of shoot out from the comet, okay? And if you're far enough away, those chunks of CO2 are going to shoot out. They're falling towards the sun the same way the comet is. That thing is still feeling the sun's gravity, so it's going to follow in the same sort of path, but maybe a little bit ahead because it got shot towards the sun.
Yep, got it.
And the solar radiation out there, far away, is not enough to quickly melt these chunks. Now, as it gets close to the sun, there's going to be so much pressure, radiation pressure, that these chunks, as soon as they get out of the comet, they're just going to immediately evaporate. And so that's why we're seeing that loss.
Yeah, that makes sense. Yeah.
Of the front-facing tail, right?
The heat, the radiation is so high that the lifespan of that tail that is appearing in front doesn't have enough time to exist before it evaporates.
So that's sort of the Quito lobe hypothesis,
right?
For why we're seeing
the sunward extension. Specifically being the thing that was weird.
Yeah. So I wanted to highlight that that paper because I thought that was a quite interesting physical model.
Yep.
That's out of Harvard Astronomy.